Let's talk about certificates, PKIs, RAs, and CSRs. Now, when it comes to using public and private keys, there's basically two scenarios involved here. The first scenario is when you want others to send you confidential messages. In this scenario, you will give them your public key so that they can encrypt the message with your public key, and then when you receive the message, you can decrypt it using your private key. The second scenario is when you want to authenticate yourself to others. In this scenario, you will create a signature and sign it using your own private key to encrypt it, and then you will give others your public key so that they can decrypt the signature. Now, unfortunately, the main problem with public key cryptography is that you never really know with whom you are communicating with, as it is vulnerable to the man-in-the-middle attacks. Now, the public key infrastructure, the PKI, aims to prove that the owners of public keys are who they say they are by using digital certificates guaranteed by a certificate authority. Now, the certificate authority, the CA, is an entity responsible for issuing and guaranteeing certificates. We can also have private CAs that can be set up within an organization for internal communication, while most operating systems have their own certificate services. Now, for public or business-to-business communications, the certificate authority must be trusted by each party, and examples of third-party CAs would be companies like IdenTrust, Global Sign, and DigiCert. Now, certificate authorities provide a wide range of functions, like providing a range of certificate services useful to the community of users serviced by the CA. The CAs can also ensure validity of certificates and the identity of those applying for them. It can establish trust in the CA by users and the government, manage servers or repositories that store and administer the certificates, and also perform key and certificate lifecycle management, notably revoking invalid certificates. Now, here are examples of a few certificates in here. You've got the requester, you've got the certificate template, you've got the expiration date for each of the certificates as well. And then you'll notice on the left where you have the folders, you have a folder for revoked certificates, basically certificates that have been cancelled. You have the certificates that are issued, you have pending requests, field requests, and also certificate templates as well. Now, with the PKI, there are three main trust models. You have the single certificate authority model, you've got the hierarchical or intermediate certificate authority model, and finally, you've got the online versus offline certificate authorities. Now, in the single CA, here, the single CA will issue certificates to users, and users will trust those certificates exclusively by that CA. However, the issue here is that if this single CA is compromised, then the entire PKI will collapse. Now, in a hierarchical CA, you have a single certificate authority called the root. All right. This will issue certificates to several intermediate certificate authorities. We call them either subjects or leaf or end entities. Now, each leaf certificate can be traced back to the root certificate authority along the certification path, and this is referred to as a certificate chaining or chain of trust. Now, just like with the single certificate authority model, here the root is still a single point of failure. However, the major difference here is that unlike in the single certificate authority where this server has to be online at all times, in the hierarchical CA, the root CA can be taken offline, because most of the regular CA activities are actually carried out by the intermediate certificate authority servers. Now, here's an example. You can see the root CA here is the Global Sign, and then the leaf certificate authority would be the Global Sign Extended Validation Certificate Authority. Now, an online CA is one that's available to accept and process certificate signing requests and management tasks. However, because of the high risk posed by a compromised root certificate authority, a secure configuration is always needed, and this will involve making the root an offline certificate authority, meaning it will be disconnected from any network and will only be brought back online when necessary to add or update intermediate CAs. Let's talk about the registration authorities and CSRs. Now, registration is the process by which end users can create an account with the certificate authority and become authorized to request certificates. So basically, users just can't come in and begin requesting for certificates. They'll need to create an account first and then be authorized to request for certificates. So when a subject wants to obtain a certificate, it will complete a certificate sending request, a CSR, and will then submit it to the CA. The CA will review the certificate and checks that it is valid. And if the request is accepted, the CA will sign the certificate and will send it back to the subject. Thank you for watching. I will see you in the next class.